Good morning, Algebra 2. I'm going to try to talk a little lower. For some reason, I'm on my, to do this video today, I'm actually using my document camera, which I hate using, which is why it sounds different and is going to be a different quality today. When I did a demo earlier, I realized like for some reason the mic gain was extremely high and I couldn't get it to turn down in time, and I didn't want to waste my time. So if you need to adjust the volume accordingly, I totally understand. Today we're going to be talking about the rules for exponents and how you combine them depending on what you're doing with them. And there are 5 main rules we're going to be using today and looking at. First of all, when we're talking about exponents and applying the rules to them, there's only a certain case when that happens. It does not happen when we have like terms. For example, we have 9x squared y. Actually, let me zoom in there a bit. There we go. We have 9x squared y minus 10x squared y. Think of x squared y as the last name. So all we're doing is counting how many of these x squared y's we have. 9 minus 10 would give us negative 1 x squared y. My pen is kind of faded a little bit. Let me see if I can go ahead and maybe switch it out or get something to write with underneath. All right. And then, for example, another time when we don't worry about the rules of exponents is when we're just combining like terms again. Subtract 6w from 8w. If we're going to subtract 6w's from 8w's, that gives us negative 2w's. This pen is really about to die on me. Let's try a different one. All right. So let's get into the rules of exponents. Now, this stuff you guys already know. This is just combining like terms. Here is where the rules for exponents, the new rules, I guess, if you wanted to, are applied. Our first rule is the product rule. Whenever you have two numbers with the same base, but with different exponents, and they're being multiplied, like we have here in the middle, the rule is you keep the same base, the x, and you add the exponents, a plus b. So, for example, number 1, h squared times h to the 6. That would give us h to the 2 plus 6 power. H to the 2 plus 6 power is h to the 8. I was boxing my answer there. And we're going to apply that again for number 2. For number 2, although we have some more terms, the rule still applies. First of all, we take our coefficients, negative 2 times 7, just multiply those out like normal, and that gives us negative 14. Now we use our product rule. We have a squared times a to the 3rd. A to the 2 times 3 power means we're going to have a to the 2 plus 3 power, which is a to the 5. So all I did was add the 2 and the 3 to get the 5. Now we have the b. We know the base is going to stay b. We have a singular b, or a variable by itself, means you just really have it to the first power. So the first power times the first power, or 1 plus 1, gives us b squared. So negative 14 a to the, my bad, it's a to the 6. I don't know why I said 5. Wait. It is supposed to be 5. On my original notes, I had 6. So I was right the first time. There we go. So sorry about that little distraction. There's our answer. Now, moving on to the next one. We have x to the a power with b on the outside. This is what we call the power rule. That's when you have exponents inside parentheses being taken to exponents outside parentheses. The rule for this is going to be you keep the same base, in this case x, and you multiply the a times the b. And whatever number that gives you is your new exponent. So for example, number 1 over here on the right, x squared to the 3rd power. So we keep the same base of x, and we multiply the inside exponent times the outside exponent. 2 times 3 gives us x to the 6. And then let's look over here for number 2, right below it. We have negative 2m to the 5th power squared times m to the 3. So they're actually going to go back and use the power rule, and then we're going to use the product rule. So let's take care of this first part. We know we're going to have negative 2 to the, we're going to keep the negative 2 just as is. And actually, yeah, negative 2 and the m. And then we have 5th powered. And then I have an issue with this. I'm kind of trying to mitigate really quick in my head. Okay, let's see. All right, I'm going to keep it as is for now. So 5 times 2 would be 10. Although I want to say that negative 2 squared is going to be negative 4. And I think it's exactly what it's supposed to be. I don't think it's supposed to be negative 2. I think I'm supposed to do negative 2 squared first. Yeah, I'm going to go ahead and just do that. Negative 2 squared. Negative 2 times negative 2 is positive 4. So there we go. 4m to the 10th. I have to. Let me rewrite all this because it just looks so nasty. 4m to the 10th. There we go. Times m to the third power. What's that going to give us? So now I have to go back and use my rule from before. 4m times 1m, because there really is an invisible 1 there, is still going to be 4 with the m. M to the 10th times m to the third, our product rule back up over here says we add those exponents, so 10 plus 3 would be 13. 4m to the 13th power. There we go. Can't forget this, that if I have a coefficient with an exponent on the outside, I have to take this to that power. Negative 2 squared, in case you're just confused where I got this 4 from, means negative 2 times negative 2. A negative times a negative is a positive. So 2 times 2 would be 4. All right, now quotient rule. When you have the fraction form of exponents with the same base, all you do is keep the same base, and you take whatever the top exponent is and subtract the bottom exponent. So let's go ahead and look at number 1. First of all, let's just deal with this math. Can we divide 27 by 4? Well, by 42. Well, we can't necessarily cancel it out, but it can simplify. We can divide both the top and the bottom by 3. So when we do that, let me make a new fraction bar over here. 27 divided by 3 is 9, and 42 divided by 3 is 14. Now we're going to have an x. We have x to the 5th on top, and then x to the 1 on the bottom. So the rule says top exponent minus bottom exponent. 5 minus 1 is x to the 4th power. Now, I have all this extra space in the denominator because sometimes things can go down there, as you'll see later on. But for right now, nothing happens, so just to make this look a little nicer, what we have is 9x to the 4th over 14. All right. Now let's go ahead and look at our second example. Y squared over y to the 4th. So first, before we can do the quotient rule, which is the new rule, we have to take care of that numerator stuff. So y squared. Well, according to the power rule from above, whenever you have inside and outside exponents, you multiply them. So I keep the same base, y. 2 times 2 is 4. And I have y to the 4th on the bottom. Well, this should be pretty obvious, hopefully. So I have the same thing on the top being divided by the same thing on the bottom. Now, if you could, hopefully, there's 2 ways you can see this. If you're pretty decent with understanding mathematics, you see when you're dividing the same thing on the top and the bottom, you automatically get a 1. But let's say you want to take an upper level and you want to prove mathematically with what we just learned why it's 1. Well, you would say, okay, I'm going to take y to the 4 minus 4 or 0 power. Anything to the 0 power is always going to be 1. So that's like a little special rule there. I'll put a little star next to that. Any number to a 0 power is always going to be 1, no matter what. You actually learn the hardcore proof of it if you take upper level mathematics in college like I did. I don't remember it that well because it wasn't that impressive to me. I'm sorry. So yeah, there's that. But I'm sure you guys really don't care. If not, Google it, look it up on YouTube, and live your life and love it. All right, now negative exponent rule. These are the ones that get kind of tricky for some students, and they really shouldn't be. Whenever you have a base with a negative exponent automatically means you're making it a fraction. So you keep the same base, and instead of having a negative exponent, you just lose the sign, and you have now a positive exponent. That's all that means. So let's go ahead and look at number 1. Number 1 is kind of broken up into 2 parts. We have negative 5 times x to the negative 2 power. So negative 5, I can write it as negative 5 over 1. I'm going to separate it for a reason. Times x to the negative 2 power. Or according to our rule, whenever we have a negative exponent, I'm going to drop it to the bottom and keep the same exponent without the negative sign. So I have that. According to the rules of fractions, you multiply straight across the top. Negative 5 times 1 is negative 5. And straight across the bottom, 1 times x squared is x squared. So negative 5 over x squared is my simplified form. I didn't box this one up. There we go. Now let's go ahead and try this again. In this case now, 4 over 8 can't be simplified as a fraction. 4 over 8 simplifies to 1/2. So that takes care of the 4 and the 8. So I'll kind of just cross them out. Then I have the k's. According to the quotient rule, I have to do k to the 2 minus 5 power. So actually, I'll just write right here. K to the 2 minus 5 means k to the negative 3 power. All right, so let's go ahead and rewrite this again. I have that 1/2 in front times, what does k to the negative 3 power means? That means I'm going to have fraction with k on the bottom and a positive 3 attached to it. So multiply straight across the top. 1 times 1 in my numerators is 1. 2 times k to the third power is 2k to the third power. And that's my final answer. You can't go any further. And then finally, that rule I showed you 2 examples above, the 0 exponent rule. Anything to the 0 power is always 1. So let's look at number 1 right here. We have 7, which is just a number 7, times x to the 0 power. Well, what's anything to the 0 power? 1. So 7 times 1 is just 7. Now let's go ahead and apply a couple of the rules together. On the top, we have w to the 4th power squared. W to the 4th power squared, 4 times 2 is going to be 8. So I have w to the 8th power, w to the 8th power on the bottom. And here we are just proving now with the laws of exponents how we get a 1. So what I have is 8 minus 8 because I have the same base. W to the 8 minus 8 power is w to the 0 power. And anything to the 0 power is 1. Or like we discovered below, when you're dividing one thing into itself, it fits into itself perfectly one time because it's exactly itself. If you understand what I'm saying. So those are your notes for today. Let's talk about your assignment now. Attached is your assignment. And no, you are not going to do all 38 of these examples. Problems. You could if you wanted to, but I am sure not going to make you do it. But knock yourself out. You're not getting any extra credit if you do, but you can sure go to town. Here's what I'm going to do. I want you guys to do from 1 through 30. But you're not going to do all 1 through 30. Here's how I'm going to break it down. So we can cross out from 31 through 38. Let's see who's paying attention to the video. Now, if you are in my 5th period class, you guys are going to do the odds. And if you are in my 9th period Algebra 2 class, you guys are going to do the evens. I wrote evens because I apparently don't know how to spell evens. So odds, 1, 3, 5, 7, 9, all the way up through 30, which is 15 problems. And the same thing for the even people too, for 6, 8, 10 up to 30. So that's all you have to guys do. It'll be due, let's make this by the end of the day, Thursday. All right, and that's all we're really going to do for the end of this week. I'm sorry I'm not on camera myself. With this laptop, if I turn the camera on, I have like the sun behind me, and I look like an angelic figure, and I know you guys think of me already like that, but I don't want to make it over-exemplified and give you the wrong idea of me being some kind of angel with the lighting behind me. So, whatever. I'm sure you guys don't care if you don't see my face. If you have any questions, feel free to ask me, and best of luck on this assignment.